Hi everyone, we now learn about the tan of x substitution for integration. That is, the method of substitution in which we change the variable from x to t, which in turn equals to tan of x. And in just a minute, I'll work through the example that we have here. But let me start by pointing out that the substitution t equals to tan of x should be used as soon as we have an integral of the type we see here. Indeed, the substitution that we learn here will always work provided that no more than one of the coefficients on the denominator, so b, c, or d, equals to 0. So this substitution will work for either of the integrals we see on the screen right now. Alright, that being said, let's go ahead and work through this example. We're told, using the substitution t equals to tan of x, to find the integral I, which is equal to 1 over 1 plus sine squared of x plus 3 cosine squared of x. Now to do this, we follow 3 steps. The first step, which is the longest, is to rewrite our integral in terms of the new variable t. Now what that means is that we need to rewrite this sine squared of x as well as this cosine squared of x in terms of t, and we need to rewrite this dx in terms of t as well. Let's start with this sine squared and cosine squared. Now the trick here is to use our knowledge of right-angled trigonometry. And here's how that works. I start by drawing a right-angled triangle, something looking like this. There's my right angle, in which we have an interior angle, x, and I want to make sure that tan of x is equal to t. Now since tan of x equals to the opposite over the adjacent, a quick and easy way to make sure that tan of x is equal to t is to say that the opposite side length is t, and the adjacent side length is 1. And we can see quite clearly now that the tangent of x is equal to t over 1, which is t. And that's perfect since it corresponds to our change of variable here. Now that that's done, we can use this right-angled triangle to come up with expressions for both sine and cosine in terms of t. And for that, let's quickly state what the hypotenuse would be. It would be the square root of 1 squared plus t squared, so that's 1 plus t squared. Done. And now we can go ahead and state that the sine of the angle x is equal to the opposite over the hypotenuse, so that's t over the square root of 1 plus t squared. So let me just write that. That's t over the square root of 1 plus t squared. And in a similar way, we can state that the cosine of x is equal to the adjacent over the hypotenuse. So that's 1 over the square root of 1 plus t squared. And now, squaring each of these two results, we can obtain expressions for sine squared of x and cosine squared of x. Indeed, we can now see that sine squared of x is equal to t squared over 1 plus t squared, and cosine squared of x is equal to 1 squared, so that's 1 over 1 plus t squared. And now using these two expressions, we'll be able to rewrite sine squared of x and cosine squared of x in terms of t. Alright, now that the sine and the cosine are taken care of, we need to take care of the dx. Now we know that t is equal to tan of x, and so using our knowledge of differentiation, we know that the derivative dt dx can either be written as secant squared of x, or we can write dt dx equals to 1 plus tan squared of x. And now we need to choose between these two possibilities. And for that, we keep in mind that what we're trying to do here is rewrite this dx in terms of t. And t, remember, is equal to tan of x. And that suggests we use the second result here, since 1 plus tan squared of x will be 1 plus t squared. So with that in mind, we can now write dt dx is equal to 1 plus t squared, and rearranging that, we find that dx is equal to dt over 1 plus t squared. And we've now rewritten dx in terms of t. Now that that's done, using the results we found, we can rewrite our integral I in terms of t. And we can go ahead and state that I is equal to the integral of 1 over 1 plus sine squared of x, which is t squared over 1 plus t squared. So I just write that. That's t squared over 1 plus t squared, plus 3 cosine squared of x. So that will be 3 over 1 plus t squared. So that's 3 over 1 plus t squared. And finally, we replace this dx by the expression we have here. So that's dt over 1 plus t squared. And as such, we've now completed the first step. We've rewritten this integral in terms of t. But for the sake of doing things properly, let's write all of this in its simplest form. And for that, the first thing I'll do is take care of this denominator here and write everything over 1 plus t squared. So let's see, that would be equal to the integral of 1 over 1 plus t squared over 1 plus t squared. All I've done here is write this 1 over 1 plus t squared plus t squared over 1 plus t squared plus 3 over 1 plus t squared. And that multiplies dt over 1 plus t squared. Carrying on, that's equal to the integral of 1 over 1 plus 3 plus t squared plus t squared. So that's 4 plus 2t squared over 1 plus t squared, with our dt over 1 plus t squared at the end here, 1 plus t squared, there we go. And that becomes the integral of 1 plus t squared over 4 plus 2t squared, with our dt over 1 plus t squared at the end. And we quickly see that these 1 plus t squares cancel each other out, leaving us with I is equal to the integral of 1 over 4 plus 2t squared. And that's our first step done properly. We've now rewritten the integral in terms of the new variable t in its simplest form. And now that we've done that, we move on to the second step, step 2. And in this step, we integrate with respect to t. And to integrate this, we use one of the standard integrals. And using either of the two results that we have at the bottom of the screen here, we can integrate this. Now, I personally have a preference for the second of these two results. And to use it, I need to make sure that I have a 1 here instead of a 4. And here's how I do that. I go ahead and state that the integral I is equal to 1 over 4 times the integral dt over 1 plus 2t squared over 4. Simplifying that a bit, that's equal to 1 over 4 times the integral of dt over 1 plus t squared over 2. And finally, that's equal to 1 over 4 times the integral of dt over 1 plus t over root 2 squared. And now that the integral is written this way, I can see quite clearly how to use the second result we have here and state that I is equal to the square root of 2 over 4 times inverse tan of t over root 2 plus some constant of integration, c. And that's the second step done. We've now integrated with respect to t. And so we move on to the third and final step, in which we write our final answer in terms of x. So remembering that t is equal to tan of x, we simply replace the t that we have here by tan of x. And we state that I is equal to the square root of 2 over 4 times the inverse tan, or arctan, of tan of x over the square root of 2 plus some constant of integration, c. And that's the final answer. And there we have it. We now know how to use the t equals to tan of x substitution for integration. And that's it for this tutorial.